really important as we try and work through some problems. And I think by the time we go through this one and then we'll look at another one today, you'll have 2 for homework. I think you'll get an idea as to how to enter the data into the calculator. So I'm going to go to my calculator. The tricky thing about this is that I just have to keep bouncing back and forth between one screen to the other, but we'll make it work. So if you haven't already entered this data in, L1 is always the first row or the first column. So in this case, we're looking at a row. So L1 would be the first row. It also represents the X values. So L1 is X, L1 is the first row across the table. Or if it's left in the table, then it's that left value. And then L2 represents our Celsius, and that would be the second row or the one on the right if it was a vertical table. So we're going to have that entered in. This warm-up, the first thing it wants us to do is graph the scatter plot. And that's what we did on Friday. So on Friday, you had your age versus the actual age of the famous person that was chosen. And we graphed the scatter plot. So just a little bit of review about how to get it to graph. The first thing I'm going to check is by going to second y equals. This is the first set of directions on that direction sheet. I need to make sure that my plots say on. If they don't say on, that's when you need to hit enter and you need to hit enter. But you need to make sure that the on is dark highlighted blinking in this case. Every time you put a new set of data into your calculator, so you're entering new data in the calculator, you always must graph it. Just entering the data into the calculator doesn't actually tell the data to analyze that information. It's just in the calculator. But every time you enter it in, you need to make a new graph so that it's graphing the new data that you placed in your calculator. To do that, we're going to hit the zoom button. Remember, zoom is at the top of the calculator, right in the middle of those gray buttons. And then it's going to be number 9, where it says zoom stat. So there should be the data that I have created from using the Fahrenheit versus the Celsius, the temperatures. Now this question says to graph the scatter plot, and then it says write the window below. Well, if I look at the top, I have a y equals, and then I have a button named window, and then we have the zoom, a trace, and a graph, and we'll be using all 5 of those functions throughout the year. We're actually going to hit the window button. The window is pretty much what my calculator, the screen that I see, is counting by and what the x-axis and the y-axis are going to. So how big or how small, how high, how low those values go. So if you hit window, you then see that there's a whole list of different numbers here. The x min and x max tell me the value the x starts at and then the value the x stops. And the scale are those little tick marks on your x-axis. Each one of those little tick marks is counting by 5. That's what the scale means. For the minimum, it's the same way. So the lowest value on the y-axis is -17. The maximum value is 117. And again, the scale is 5. We should all have the same information. So that is a way that I can tell if you graph this correctly. Because we're all entering the same data into the calculator is going to graph it for us by plotting those points. So therefore, it's the same points for everybody, and the way that I can see if you graphed it correctly is by asking for your window. So before I move on to the next question, does anybody have questions about getting the window up? So the window tells me that you've graphed your data correctly. That's what I'll be asking for instead of looking at everybody's graph or having you graph by plotting points. That takes a lot of time to plot points when you're graphing larger numbers. So questions about how to get the window or what the window represents, why I have you show the window.
Yeah, I got 1 for my scale. I don't know.
Do you have the rest of the numbers correct, Valerio?
Yeah,
Okay,
they're all the same except the scale.
except the scale. All right, that's all right. I'm not too worried about the scale. It's the X max, X min. I don't know why. You probably just have a whole bunch of little tick marks or no tick marks at all. Anybody else? Questions, concerns?
I had 1 too.
You had 1 as well?
Yeah.
Okay. I don't know. What did you get?
I got 1.
You got 1.
Yeah.
Okay, maybe it's dependent upon the version of your calculator. I bet that could be.
Mm-hmm.
But the other values should be the same. Any other questions? Okay, so that's question number 1. You don't have to worry about the values down below. If you have values down below, or you might not, so you don't need to worry about writing those. It's just those 6x, 3x values, 3xy values that we're focusing on. So the next question, it says, give the equation of the best fit line, also known as the linear regression equation, and then it says to round to 2 decimal places. So on the directions for your calculator, you're looking for the directions that ask you to create the best fitting line or the linear regression equation. To do that, we're going to go back to stat, because now we need to try and get the calculator to actually calculate and analyze this data besides just graphing it. How does it relate to x and y? Because if I go back to my graph, I see it's an increasing graph. It looks pretty linear. It looks like all of these points are lying on a straight line. So we want to know, what is that line? So what line would create this set of points? So we're going to hit the stat button. We already edited the data, but now we're going to do some calculations. So you're going to arrow 1 over to where it says calculate. Now there are a couple of different things if I look down this row, and we will be using different ones kind of depending upon what we're looking at. The one variable statistics would be if I had one set of data and I was trying to find out like a mean or a median, a range, a mode, quartiles, like that we'll use later on. If you go down to number 4, it says linear regression, and then it has that form ax plus b, very similar to mx plus b. That's what we're using because we're trying to write an equation of a line. If it looked like it was some type of curve, then I would use 5, 6, or 7. So 5, 6, and 7 are once it becomes a curved graph instead of a straight graph, a line graph. But we're going to hit number 4. So linear regression number 4, my slope mx plus b form, ax plus b. So at this point, you don't do anything, I just need to calculate. And it depends on what your screen looks like. It might look a little different than mine. But I need to make sure that I go down. You might have to hit enter 3 times, maybe 4, and I'm going to hit calculate. This gives me an A value for the slope and a B value for the y-intercept. You're going to take those two numbers, round to 2 decimal places, and write an equation of the line. So if I'm writing an equation of a line, I would have 0.56x, I'm replacing A with the slope, rounding it 2 decimal places, and then my B value is negative 17.78. So y equals 0.56x minus 17.78. That's the equation that represents this line. So if I go up to y equals, I'm going to go into y equals, I'm going to plug this equation into the calculator. So 0.56x, oops, that wasn't x. And I'm going to type in my minus, and then 17.78. So this is just a way to check our graph. So when I hit graph, I see that those points fall on that line. So that's the best fitting line, the line that fits to the majority of the data. Now there's a direct relationship to these points. Each point falls on the line, and that's because I can create, they're kind of like the same type of measurements. So I can move from one equation to the next or from one temperature to the other temperature. 0 degrees in Celsius is 32 degrees in Fahrenheit. So it's a direct correlation. Any questions getting that? So I want you to be able to make sure you're asking questions so you're understanding all the parts of the calculator. Okay, the third step says, what is the correlation coefficient? Does anybody remember from Friday what letter we said the correlation coefficient represented?
R.
R, nice job, Annabelle, thank you. It's an R. So if I go back to my regular calculator screen, we need to get R. And in the last equation we just came up with, we had an A and a B. The last set of directions, so on the set of directions, there are 4 things for you to do. The very last set says creating the correlation coefficient. And to do that, I need to hit the second button, which is at the top, and the 0, the actual number 0. Above 0, it says catalog. These are all the functions in your calculator. So anything that my calculator can do is in my catalog. You're going to go down to where it says diagnostic on. You can scroll down, you can type the letter D in, but I'm looking for diagnostic on. It's in alphabetical order. Oh, right here it is. So once I see diagnostic on, I'm going to hit enter, and then I'm going to hit enter one more time, and it should say done. So that means the calculator now has pulled this information into its function or into its statistical set of data. So one last time, I'm going to go back to the stat button. We're going to move over to calculate, and I'm going to hit number 4 again. And then I'm going to go down to that calculate. And now I see that I have the A, which is still the slope. I have the B, which is the y-intercept. I have r squared. We're not going to worry about r squared. You'll do that if you take CHS Prob Stat. But then we have r. These two numbers actually are the same today, but they won't, or right now, but they won't always be the same. But I can see that my r value, the correlation coefficient, is 1. Annabelle, do you remember what the correlation coefficient told us about the graph from Friday?
It's like how well a line fits the set of data.
Yeah, very nice. And if it's equal to 1, it's fitting it perfectly. So that R value tells how close the points are to creating a perfectly straight line. If it's 1, we have a straight line. And if I look back at my graph, I can see that it is a perfectly straight line. Those points all follow on the line, all at the same place. So they're all on my line, making it a perfectly linear graph. So the data is perfectly linear when the R value is 1. Questions? So as I said, we're going to work through an example today. We're going to use the calculator again, placing in new sets of data. And then we're going to start interpreting and analyzing what this means. So yes, I want you to be able to use the calculator, but we also have to understand what does it really represent with the context of our problem. So in your packet, we are going to look at section 2.6. So we did the vocab on Friday, and today we're going to do, there's 2 problems. We're going to do 1 problem today, 1 problem tomorrow. So we're on page 20. And on page 20, we have a table of values. And at the top, it tells you that it's the high school football players talking about their height for X and the weight for Y. So I'm just going to write us a little reminder. Just like a T-chart, the X is on the left, the Y is on the right. So this is page 20 in your packet. So we're going to see if we can kind of graph this, create a scatter plot, find that best fit line or the linear regression equation, find the correlation coefficient, and then underneath that, there's other questions that we're going to try and use the equation for. So once we get that equation, we're going to see if we can try and answer parts of that equation or interpret parts of the equation. So the first question here, it says make a conjecture about the relationship between the height and weights of football players. I think a conjecture sounds like a science word. Sometimes in science you think of like making a hypothesis, making a conjecture, an educated guess. That's I know definitely a science term there. So can somebody look at this information and describe the relationship between the height and weight of football players? So look at the height, look at the weight. What kind of conjecture, hypothesis could you come up with? And it doesn't even need to be football players. I think this is kind of in general as well. Ava R., what do you think you could kind of decide about the height and weight of football players?
I'm sorry, can you repeat the question?
Yeah, what kind of conjecture could you make about the height and weight of football players?
The taller you are, the heavier you are?
Sure. And that makes sense pretty much up until a certain point, and then you stop growing. So hopefully once you stop growing, maybe you stop gaining weight as well. But if you have a little sibling or maybe a little cousin, as they grow taller, they're going to gain more weight. So the taller you are, the more you weigh, or the heavier you are, however you want to word that. So I'd like you to go into your calculator and see if you can follow the directions of the calculator. You're placing the L1 as the height and the L2 as the weight. So see if you can make those values in your calculator. I'm not going to switch over to my calculator screen right now. I want to see if you can try and get the numbers in your calculator. Follow the directions. So you need to go to Stat. You need to edit the data. To clear the data, remember you use the up arrow and you hit clear and then enter, and that clears out all your data. So if you use the up arrow and take it all the way up to the top, hit clear and enter. Never hit delete. Just clear, enter. It wipes out all your data. And I'll give you a minute or two to get the data entered in. Make sure you're carefully typing in the numbers, double checking. You need to make sure you don't skip a number. Each value needs to line up with L1 versus L2. Does anybody need help? Not sure what you're doing right now. If you're afraid to ask, send me a chat if you're not sure how to enter something in the calculator. All right, so after you have your data entered, remember you need to go to second y equals, and then you're hitting zoom number 9. Look at your graph, see what's happening with your graph, and then hit the window button. And once you have the window, This is where we should all have the same exact information. So you're writing down the window values. Anybody want to be a brave volunteer and give me the window values you found? Jaden, were you able to create the data? Do you think you could give me your window?
Sorry, I'm still trying to figure out how to get to the scatter plot.
Okay, so
Yeah, from the stat.
that's all right. Let's see if we can look at that. Okay, so you have the numbers in. We're going to hit the second button at the top. We're going to
Okay.
hit y equals.
Mm-hmm.
And then we're going to hit zoom.
Oh, that's what I forgot to go to Zoom. Okay.
Zoom, yeah, and then number 9.
All right, there we go. Oh, all right. So for the X min, I got 60.8.
Okay,
For the X max, I got 75.2. And then the X scale, I got 1.
good. And then how about the y values? You're doing great.
Y min, I got 113.95. Y max, I got 201.05. And then the scale, Y scale, I got 1.
Awesome, nice job. So again, before I move on, does anybody have questions? Okay, so then the next thing we're going to do is we're going to use the calculator and we're going to try and create the equation. So remember, to use the calculator, you need to go back to stat, move over to calculate, and then we're hitting number 4. So I'll pull up my calculator again so we can look at it. So we're going to go to stat, move over to calculate, always number 4, linear regression in the form mx plus b, or there's an a there, that direct variation, that a value. Still a slope. And it says to round to 2 decimal places. So make sure you're rounding correctly. Write your equation, 5.33, make sure you round. And then we have our x, minus 209.48. Again, make sure you round. And then part D says what's the correlation coefficient? That's just the R, that last value. And it's 0.84. So that's all we actually need the calculator for. The rest of this worksheet is kind of analyzing and interpreting. Alyssa, question.
Yeah, I have 2 questions. Whenever you put in the numbers into the calculator, do you put it in order?
Yes.
And then do you repeat it if there's the same number?
Yes. So,
Thank you.
yep, I'll bring up my calculator again. So here is, like, in order as it's listed, every single value. So even if it's repeated, that's okay. It still needs to be there, because somebody that is 68 inches tall might not be 145 pounds. They could be 140, they could be 150. So just because we all might be the same height, we might not all be the same weight. So that's why we need to make sure we're accounting for each piece of data that was given to us in the problem. Really good question. Other questions? All right, so we're going to see if we can now do the analyzing and the interpreting. Go back to my regular screen. There it is. Okay, so these are the 2 pieces of data that we had. So we graphed it. We got the x-min, the x-max, those window values. And then the calculator gave us the equation and it gave us the correlation coefficient. So underneath the correlation coefficient, it says, what does this value mean? And that's talking about the R value. Can anybody explain what that value means? Knowing that the warm-up that we did, it was 1, R equals 1, and it was a perfectly straight line. So that's the warm-up that we looked at. It was a perfectly straight line when the R value was 1. Maddie, could you try and explain what 0.84 means?
Do you want like describing word like positive, negative?
Yes, yes.
Okay. I don't know if it would be no correlation or if it would be something else, because on the notes we just had positive, negative, and then no correlation.
Okay. What else for the definition of the correlation coefficient? What else do we have there besides it like being positive and negative?
It was the range of the number R from -1 to 1.
Okay. So the range from -1 to 1. How close would you say 0.84 is to 1?
It's pretty close.
Pretty close, yeah. It's not 0.95, which would even be closer. I mean, we're like 16 hundredths away. So we could say like the data falls with a group, like it kind of looks like it's a group of points that are increasing. You could say it's a fairly straight line. It's definitely not a perfectly straight line like we had on the warm-up. So however you want to word that. Not very scientific or mathematically here. So it's not a perfectly straight line. If that number was 0.95 and above, the points should look very close to being linear. And that's when I would say it's very close to being linear. In this case, we have got this group of points, so not all of them would be following on my line. Questions? But it is positive. So it's increasing, it's a positive correlation. All right, now we're going to continue to see if we can kind of predict and analyze. Part E says use your equation. So that's the key part. We're not using the data above. We're now using the equation. The equation is like the average line. That's what the best fitting line means. It's the average. It's the line that's in the middle of the graph, the middle of the data. Once you have the equation, we try and use that equation to help us answer some questions. So use your equation to predict the weight of a football player whose height is 5 feet 11 inches. And then it says show some work. So we have this equation. And it asks us to use the equation to figure out what would the average person weigh. So on average, if we're 5 feet 11, what would the average of that weight be? That's what this question is really asking. So a linear regression equation, or a best fitting line, is the average individual. If I took all of those people that were 5'11", what would their average weight be? Valerio, do you know what we should do with that 5 feet 11 in order to kind of predict the weight of the football player?
We should convert it into inches and then plug it into the equation.
Awesome. How many inches would that be if you're 5'11"?
71.
71. So he said convert it to inches and then plug it into the equation. That's our x value. Remember, the height is the x, the weight is the y. Were you able to do that, Valerio?
It's 168.95.
Awesome, thank you. Nice job. So if you're looking in the table, I see that somebody is 71 inches in the table, and that person that's 71 inches in my table is 155 pounds. But again, that's just one person from the data that we collected. My line represents the average overall, the people that are 71 inches on average. Ava, question.
So does the 168.95, that's how much they weigh? Or is,
Oh, I put inches, huh? Yep.
yeah, sorry, I didn't mean
Nope.
to correct.
No, I'm glad you did. How about pounds?
Okay,
That's
thank you.
usually how we measure somebody when they weigh something, huh? Thank you. Other questions? So 168.95 pounds. That would be a really tall person. Maybe a tree is that tall, but I'm not sure a person is that tall. All right, so there's a couple other questions underneath here, kind of using what we've done in chapter 2, and we're just extending that information. So letter F, what's the slope? Riley, R, what's the slope of this line?
5.33.
Yeah, 5.33. So that's our slope. And that slope, if I was thinking about what it means, because it says what does it mean, if I want to label this 5.33, it would be pounds per inch. Remember, slope is y over x, or rise over run. My y is pounds. That's my rise value. My run is inches. So we need to explain what it means. This should be a sentence. So now I'm taking math and I'm making it seem a little like English. What does it mean? So if I have the slope of 5.33 pounds per inch, what would that really mean in real life? Like, what are we talking about? Brooke, do you think you could take a shot at it? What do we mean when we're talking about slope here?
For every inch, you gain 5.33 pounds.
That's perfect, Brooke. I love it. So you're using two things there. Slope is something that happens over time. It's a continual happening, in this case, increase. So for every inch, the more you grow, in general, you're gaining 5.33 pounds. And again, that's on average. The y-intercept in this question, well, the slope is m, the y-intercept is b, but we're writing our y-intercept as an ordered pair. So remember, the x value is 0, the y value is negative 209.48. Remember, x would be our inches, the y would be the pounds. Now here's the part that sometimes doesn't make a lot of sense, because we're taking a math equation and we're trying to correlate it to real life. Sometimes equations don't know about real life situations. In this case, it says, what does it mean? Technically, this is saying if you are 0 inches tall, because that's what the y-intercept means, it's crossing the y-axis, then you weigh negative 209.48 pounds. Well, we know that that cannot be true, but that's what the data is telling us, because the y-intercept happens to go low on the graph. Oh, I'm writing it at the wrong place. So that question may not always make sense. There are times where it will make sense, but I mean, if you're 0 inches, you shouldn't weigh anything. You don't exist. So math's way of saying you don't exist, in this case, correlating it to the data we have, it's making it a negative y value. That's okay. Don't change the numbers. These are the numbers that were given. Any questions? So think about, what's the 0 represent in the ordered pair? What's the y represent in the ordered pair? Try and write a sentence with it. So if you're 0 inches tall, you're going to weigh negative 209.48 pounds, which we know is impossible. But again, if you're 0, then you aren't around as well. You don't exist. So there's one other question on here, and it's finding the x-intercept. To find an x-intercept, we need to take our equation. So we're using this equation, and the x is when we have an x value and our y is 0. That's how we found an x-intercept in 2-4. So we're using the information from 2-4 to help us kind of interpret the information right now. So I'm going to take that same equation and set it equal to 0. So this section is all about pulling stuff together. So pulling the information that we talked about before together to see if we can try and analyze it now. So I need to find x because it's an x-intercept. We have to get x by itself. I've got to divide by 0.53 or 5.33. And then we get an x value of 39.30. Remember, an x-intercept is an ordered pair. And this represents inches versus pounds. So I tried to squeeze in a little last part there, thinking about the meaning of the x-intercept. It won't always make sense. Technically, this is saying if you're 39.3 inches tall, then you're not going to weigh anything. Well, we know that's not the case because there's probably a whole bunch of little kids running around that are 39 inches tall, and they definitely weigh more than 0 pounds. But that happens to be where the graph crosses the y-intercept. So before I let you go, I want to just show you what the homework looks like because there's one little thing with the homework that we have to try and correlate. So there are 2 questions on the homework that are exactly like the one we went over. So you get 2 of them to practice. Except in this case, instead of saying pounds and inches or inches and pounds, we're talking about years and a percent. The key thing when you're using a year is that you cannot actually plug the year into the calculator, and this is the most important thing here. I cannot plug in 1984 in the calculator because the calculator is thinking you're using a number 1,984. Instead, we use values to represent years, numerical values to represent years. And in this case, they're saying 1984 is year 0. Now, I know you're saying, Mrs. Kane, this data is so old. Yes, it is old, because this is true factual information about percentage of households owning computers. And in 1984, most households didn't have a computer. Even in 1994, most households didn't use a computer or have a computer. We had one. It was really old and it had a green screen. If you're a computer person, you might know what I'm talking about. So instead of using the year, you're going to use numbers to represent the year. You'll do that for the same side on the next page. So we're going to do more of this tomorrow. So you might still be like, I'm a little fuzzy. That's what homework is for, practicing the homework. We're going to go over another example tomorrow. We'll wrap it up on Wednesday. Have an awesome day. We'll see you tomorrow. If you have questions, you can fill out that homework questionnaire so that I know what questions to kind of look at tomorrow morning.
Miss Kane,
Yes.